Good morning, Springfielders. I welcome you all for the new session of mathematics class. As you know, we were dealing with the chapter rational numbers. Let us first recall what we have learnt in our previous sessions. In our last session, we have learned properties of rational numbers under addition, subtraction, multiplication, and division. And what we observed is under addition, closure property, commutative property, associative property, all are applicable. For subtraction, closure property is applicable, commutative and associative is not applicable. Then in multiplication, closure, commutative, associative, all are applicable. And in division, closure property is applicable, but there is an assumption that the second rational number should not be equal to 0. And commutative and associative is not applicable. Now, look at the slide. Here, we will revise how to add rational numbers when common denominators with common denominators. In your previous classes, you have learned to add rational numbers with common denominators. So what is the method is to add rational numbers that have common denominators. We add the numerators, but we do not add the denominators. We keep the denominators common. Like for example, look at the picture. In the first picture, a pentagon is there which is divided into 5 equal parts. 2 is shaded, so it is 2 by 5 plus in the second picture 4 parts are shaded out of 5, so it is 4 by 5. So for this what we do is we just add the numerators and we'll write the common denominator down. So the answer will be 6 by 5. You all have learned how to convert improper fraction into mixed fraction in your previous classes. So 6 by 5, it is equal to 1 by 5. Now adding rational numbers with different denominators. Now if you have to add two rational numbers with different denominators, what you have to do? What we do is, first of all, we equalize the denominators by enlarging each rational number by the lowest common multiple, that is LCM, as the denominator. Then we add the numerators. Okay, children? Then subtracting rational numbers with common denominators. Subtraction is the inverse operation of addition. To subtract rational numbers that have common denominators, we subtract the numerator, but we do not subtract the denominator. For example, what you see in the picture, children? The first one is 7 by 8 minus 4 by 8. Here we will write the common denominator and we will subtract the numerators. So 7 minus 4 is 3. So the answer is 3 by 8. Then subtracting rational numbers with different denominators. To subtract rational numbers with different denominators, first equalize the denominators by enlarging each rational numbers by the lowest common multiple as the denominator. Then subtract the numerators. Now how to multiply rational numbers? To multiply two rational numbers, we multiply the numerators to get the new numerator and multiply the denominators to get the new denominator. For example, when you are multiplying 3 by 5 into 4 by 7, what we do? We multiply 3 into 4 in the numerator and 5 into 7 in the denominator. And the answer will be 12 by 35, which is product of numerator by product of denominators. Now, division in rational numbers. To divide two rational numbers, we take the reciprocal of the second rational number and multiply it by the first number. Like for example, if we have two rational number a by b and c by d, if they are two rational numbers, to divide what we do? We reciprocate c by d. That is, we bring the numerator down and denominator up. So a by b into d by c. Then we will multiply the numerators and multiply the denominators. Okay, children? Now, rational number between two rational numbers. How to find a rational number between two rational numbers? There are two methods for this. In the first method, what we do is we make the denominators equal. Like 1 by 4, if we will multiply 1 by 4 with 2 by 2, the answer will become 2 by 8. And for 1 by 2, if we multiply with 4 by 4, the answer will become 4 by 8. So, what did we do in this case? We have equalized the denominator. Now, after equalizing the denominator, what is the number between 2 by 8 and 4 by 8? Yes, it is 3 by 8. So, 3 by 8 is a rational number between 1 by 4 and 1 by 2. The second method is to find a rational number between 1 by 4 and 1 by 2. What we have to do is we add both the rational number and divide by 2. So 1 by 4 plus 1 by 2 we have to add, and then we have to divide it with 2 to make it half. So the answer will come 3 by 8. Now, operation on rational numbers. Rational numbers provide the first number system in which all operations of arithmetic, that is addition, subtraction, multiplication and division, are possible. Multiplication makes a number bigger and division makes a number smaller. The arithmetical operations are reduced to operations between two rational numbers. Addition. It is the first operation. This operation uses only one sign, that is plus sign, cross. Subtraction. It is the second operation. The operation uses only one sign, subtraction sign. Multiplication. It is often described as a sort of shorthand for addition. This operation uses a sign into. Then division. It is the last and an important operation. The operation uses the sign of division. Now, application and uses. Rational numbers are important. They are used in real world every day. Even though we are not thinking about it, if the number is a rational number or not, we still use them in our everyday lives, at school or in the kitchen. We even see them on the TV screen. For example, baking. Ingredients in the recipes are often listed as fractions to show the measurements, such as a half cup of flour, going into a batch of cookie dough. Half is a rational number. Commercials. Many commercials use rational number as statistics to get you to buy their products, such as 4 by 5 dentists approve this toothpaste or 9 by 10 women like this lipstick best. Now comes the time for homework. In the homework, in your last session, you have write properties of rational number under addition and subtraction. Now today you will write the properties of rational number under multiplication and properties of rational number under division. If possible, write one example of each. Okay, children? Now this all for today. See you tomorrow for the next session. Thank you.